In this lesson, we'll be covering first part of application to calculus, which is calculating the maximum and minimum. And I'll be doing a 3-part series on application to calculus. The first part is this video, where we'll be doing maximum and minimum problems. The next one we'll be doing calculus of motion, and the last video of the series will be doing the rate of change. So this is a section that a lot of learners struggle with really in Matric, and I also struggled a bit in my years when I was in high school, but until I understood the basics of it, and really once I understood all the principles, I was able to really nail and ace all my exams. So I'll be showing you everything I've consolidated, and in this first maximum minimum section, these are the 4 important steps that help you answer every single question in maximum and minimum problems. So let's just quickly go over them, and then you can take a screenshot of this. I'll write them down quickly because you'll be referencing them as step 1, 2, and 3. So the first step is always read and understand the question so that you know where you need to go and what you need to do. You can draw diagrams if you want to further understand the problem. The second step is formulating, really, and constructing 2 equations really from the unknowns, and then you'll be using simultaneous equations to solve for the 2 unknowns really. So don't mind, I've written some changes in chapter 1 because I've extracted this from the study guide I wrote to crack the maths code. And the third step is write down really the equation that you've established, right, your f of x. And whenever they ask you to find the minimum or maximum, you always really find the first derivative, then equate to 0, and then you solve for x. Really. So to finally answer your question, you have to substitute your x into the original equation, which is f of x, to find that minimum or maximum value. And then the last step is always to reread and check, make sure that you've answered the question so that we get all the marks. So I'll really minimize this, but I'll be referencing it throughout this tutorial. So as I said, if you wish, you can take a screenshot of this, and then really this will be very beneficial to you. So let's keep it somewhere at the bottom. I'm at the bottom there, so as to not forget it, not to completely forget it. So we're given this question here where the farmer wants to farm chickens, and he erects a 3-sided enclosed area against a wall. The wall forms the 4th side. So this is the really a quick schematic of that, meaning that the chickens, they'll be really living in this area here. Let's try and really look at that area. The chickens will be abiding in this territory. So all the chickens is farming will be staying in that really enclosure, just to give a visual representation. So we're told that there's a wall, and then we have sides A, B, B, C, C, D, and we have X and X and Y. So we have more or less a rectangle here. The first question that they ask us is that the farmer has 120 meters of fence material. Calculate the maximum, remember that word, keyword, maximum area. All right, so we're looking for the maximum area. So back to our steps, we have to read and understand the question, and I think we have a grasp of what the question is, and then we have to formulate the equations, 2 equations from this. So we need to go to step 2. How do we do that? We're dealing with a rectangle, and asking us about area. So what comes to mind is 2 equations. The first is the area. So the area of a rectangle is nothing more than the length times the breadth, which is, in this case, we can either choose your length and your breadth, but in essence, you will have it as x times y. That will be your area. We can label our area as A. That's our area. But what else do we know? They told us that the length of the fencing material, meaning that if you were to use the fencing material from A to B, B to C, C to D, it will be 120. And we represent that, or we know that concept to be the perimeter of something, because it goes on the perimeter of it. So the total perimeter of it will be x plus y, because we add all the sides. Remember, we don't add the wall because the wall was always there. So the perimeter P will be equals to 2x plus y, but we know what the perimeter is. the parameter is 120 is equals to 2x plus y. So you can see here in essence, because the question asked you for the maximum area, so the focal formula here will be the area formula, right? But you can't find the maximum really because we don't know what x is, what y is, but we can really isolate y on our second equation really, so that we can substitute this equation into that equation. So we can label this equation 1, we can label this equation 2, and then according to simultaneous equations we have to construct equation 3. So in this instance y will be equals to, you take the 2x to the other side, it will be 120 minus 2x. In that way we would have constructed equation 3. Then we can substitute equation 3 into equation 1, and let's see how that will look like. Remember, our equation here is area is equals to x. Where there's y, we're going to substitute 120 minus 2x. In that way, now we formulated the new equation, which is a in terms of x, because there's only x now, of 120x minus 2x squared, just multiplied in by the x. So now you can see we formulated a new equation, right? So now we move on to step 3. It says write down f of x. Remember, this is just a step, so in this case it's a of x. Now we can work this problem because they asked us to find the maximum area. So to find the maximum area according to the steps, we need to find the first derivative, equate to 0, then solve for x, then take the x value we find, substitute it back into our original equation to find the maximum. So let's go ahead and do that. Let's find the first derivative of a of x. First derivative, a of x will be equals to 120 minus 4x. So we equate this first derivative of 120 minus 4x, we equate it to 0. So now we're going to have 120 is equals to 4x, and because we're solving for x, we divide both sides by the unwanted. So we divide both sides by 4, it will be 120 divided by 4, which will give us 30, and we're using the units of meters. It means x is equals to 30 will give us the maximum, but we need to find what the area will be by substituting this x into the original equation. So let's go ahead and substitute that according to step 3. Substitute it into the original equation. A of 30 will be 120 times 30 minus 2 times 30 squared, which means our maximum area when x is 30, and just quickly we can use a calculator so as to know what you get when you calculate that. Then you get 1800 square meters, because it's area, it's always square meters. So that's the maximum area from what the farmer will get when he has 120 meters of fencing material. So that's the largest area he can get from this enclosement for his chickens, and that will be the answer for the first part of the question. That's the maximum area he can get from that 120 meters. And let's move on to the next question of step 4. Reread the question to make sure we've answered the question. We just did that. We just really connected the answer for 1800 meters to being the maximum area you can get from 120 meters of fencing material. So let's move on to the next question, where it says a local hardware informs him that the cost of the fencing material is 35 Rand per meter, and the farmer wants to erect a 400 square meter rectangular area. Okay, he wants to erect that. What must the dimensions be so that the cost is minimal, right? So we need to get the dimensions. When they mention dimensions, so it needs 2 keywords needs to come to us. So let's quickly erase that. You can pause the video and take a screenshot of that. Don't have to worry about it, or you can rewind the video. It'll always be here. So in the second question, we need to calculate the dimensions. So when they mention dimensions, they're mentioning x and y, but they're telling us something important. that the area that the farmer really wants to erect is 400. 400, that's the area. And what we know that area is given by x times y, which means we can say 400, which is our area, is equals to x times y. That's what we know. So, but when they mention dimensions, what is that? Dimension is x and y. So remember our perimeter. Our perimeter is x plus y, which is p is equals to 2x plus y. So we need meaning that our main focal formula here, which will get us dimensions, it's the perimeter formula. This is where we're going to get our dimensions. But we have x and y which are unknown. So what do we need to do? We can always really use this formula as well. We can label this equation 1 and I can label this equation 2 as well. So equation 1 and 2, we can take equation 1 because this equation 2 is our main formula. We can make y subject so that we can really substitute y there. We can make equation 3 by saying y is equals to dividing both sides by x. 400 divided by x. This will give us equation 3. And we can say substitute equation 3 into the unused equation 2. And how will this look like? This will be perimeter is equals to 2x plus our y is 400 divided by x. So we can label it as p of x is equals to 2x plus 400 over x. Now we formulated our equation or formula. So in essence, now we're in step number 3 again, right? So they're asking us for a minimal of the dimensions. P of x, the perimeter, will give us the dimensions of x and y. So let's go ahead and try and find the derivative here. But before we do that, we have to write this equation entirely with no fractions. We can just say 400 x to the power of -1. This will make deriving this equation much easier. So let's go ahead and do that. Let's find the derivative. P prime of x will give us 2 minus 400 x to the power of -2. And we have to equate the derivative to 0. So we're going to do that. 0 is equals to 2 minus 400. I'll just bring the x to the bottom to eliminate the negative exponent. And now we need to solve for x. We can do that by taking the 400 over x squared to the left hand side, which will change sign to be positive, and we'll be left with 2 over 1. What we can do, we can just cross multiply. We'll have 2x squared is equals to 400. Then what do we do? Divide both sides by 2. 400 divided by 2 will give you 200, square root both sides, and you will get 2 answers. One answer will be positive and one answer will be negative. So the square root of 200 will give us, I'm looking for only the positive answer because my dimensions need to be positive. It will be 14,4 meters. But this is only the x dimension. So how do I get my y dimension? I get my y dimension by taking the x value I calculated and substituting into my equation 3. So let's go ahead and do that. I'll be substituting it into equation 3. And my y dimension will be y is equals to 400 divided by 14,14. And my y dimension will be equals to 400 divided by 14,14. Get 28,29, and all my answers are rounded to 2 decimal places. So in that way, we would have calculated what our x dimension is and what our y dimension is. And we would have really answered the question because we were given the area The area we were given was 400, as in here, and we use that area really to substitute that equation into the perimeter equation, where p was equals to 2x plus y, and we solve these equations simultaneously. And a quick, really, I would say, a quick hint of how we knew which formula to use was the word dimensions, because dimensions only refers to x and y, and the formula that represents x and y is perimeter in that sense. And we use the area of 400 in our area formula, and in that way we would have answered the question. And if the question had asked us something else, like to calculate the cost, that the total cost, this minimal cost they're talking about, the cost will be equals to really the price times the perimeter. In this case, the price is 35 rands times the perimeter is 2 times x, which is 14,14, plus y, which is 28,29. And in this way, if you just multiply 35 times 2 times 14,14 plus 28,29, this should give us our total price. So it will be 35 rands times multiplied by, open bracket, 2 times 14,14 plus 28,29, which is the y dimension, and the price that we will spend in this material, 1,979,95 to erect that fencing for his lovely chickens. And if you found value in this video, please hit the like button and be sure to watch the next video, where I'll be doing calculus of motion, where I'll be touching on distance, velocity, and acceleration problems.